In Chapter 4, we are going to be talking about exponential functions and logarithmic functions. You have probably heard about exponential functions for about 5 seconds in Algebra 2. So I'm going to go pretty in depth with this. This section is a very long section. There are several pages to this video, so I would recommend that you watch a little, get a little bit of information, take a break, and then come back. Because this has word problems, it has a little bit of graphing, which we do more in 4.2, and then you also have some graphing calculator questions that we have to do. So for exponential functions, you have two different parent forms. This is the one that you're going to see more often, all right? And the second one comes into play when we have our word problems. If your base, which can either be a number by itself or 1 plus a rate, once we come up with that, if it's greater than 1, then you are experiencing exponential growth, which is dictated over here by this graph. Okay, we're going to talk about that graph in just a second. If you have a number that is between 0 and 1, meaning that it is a fraction that is less than 1 or a decimal that is less than 1 but greater than 0, then it would be decaying. So what this does is reflected across the y-axis, and we'll see how that works in just a minute. So let's look at this graph for just a minute. We're going to talk about the general characteristics. So what happens with these is you have to be given a base. So the one that they typically will use is 2 to the x. That's a parent graph that they use often. And when I'm looking at this, the domain doesn't look like it has any restrictions. So the domain for exponential functions is negative infinity to positive infinity. There are no domain restrictions with these. Now the range, however, is restricted. If I go bottom to top, it looks like I'm going to have a horizontal asymptote in this parent form at y equals 0, and the entire graph falls above the x-axis. So the range for this will be 0 to infinity, and because it's a horizontal asymptote, there are no brackets. So if we had the event that we were going to look at f of x is equal to 1/2 to the x, the reason that this is going to be a reflection that goes this way, because I said it reflects across the y-axis, is because we can rewrite this as 2 to the negative first raised to the x power, which is just 2 to the negative x. And we have already discussed chapters ago that when you have a negative on the inside, then that reflects it across the y-axis. The domain is still everything, and the range is still 0 to infinity, and you do still have a horizontal asymptote at y equals 0. So those are two of the basic ones that we're going to be doing. We are going to be talking about transformations in 4.2 with a little bit more dedication to detail. So when you go to graph these on MyOpenMath, you're going to be choosing the diagram that looks like an exponential growth function. For this one, I'm going to be looking at x values, and I'm going to be placing them into the equation 3x minus 2. And then that'll come up with a y value that I can plot. Now you only have to plot 2 points with this. I'm always going to tell you to use x equals 0 with these. Now the other point that you choose might be determined after you look at it for a second. But if I plug a 0 into this, then I have 3 to the 0 minus 2, which is 3 to the negative second, which is 1/9. Now the problem with that is I can't graph a 9th. So that is too small, so I need it to get bigger. So to make this thing bigger, I'm going to go up to 2. So if I do 3 to the 2 minus 2, that's just 3 to the 0, which is 1. So I go right 2 and I go up 1. And then I need to come up with another ordered pair point to use. So if I have 3, then I'm going to have 3 to the 3 minus 2, which is 1. So that would be 3, 3. So that could be 2 of the ordered pair points that you talk about. Now, if you look at this equation, what's going on, if you use transformations, you are subtracting on the inside. So this whole thing is just moving right to from its parent graph. So in the parent form, you would have started here and been at 1, 3. So we have moved 2 to the right. So my graph will be doing what it's supposed to do. It does, in fact, still have a horizontal asymptote at 0, which is a little bit hard for us to graph by hand. Your online graphing tool will do much better. All right, next one we see here, we have f of x is equal to -1/4 and then x minus 4. So this one I'm going to do using transformations. So I have a negative. I'm going to change this into 4 to the negative first power. And then out here I have x minus 4. So what that's going to change to is negative. I'm going to have a base of 4. And then this -1 is going to be in here. Now the hesitation that we have and what we want to do is to distribute that thing, but you do not want to distribute, okay? Be very careful with this. So I have a negative on the outside, and then I have x minus 4. Now there are 2 different transformations going on here, 3 actually. All right, this one is going to reflect it over the x-axis. So reflect over the x-axis. And then we have a negative on the inside here. So that's going to reflect over the y-axis. And then we are subtracting 4, so we would move right 4 units. Now, from a while ago, we knew that when we did these, we needed to deal with our reflections first. So what I'm going to do first is determine where my parent graph is. So my parent graph would be 4 to the first power. 4 to the x power. So that would be 0, 1, and then 1, 4. So there are my parent points. Now, I need to reflect this across the y-axis, which is going to put me now at here and here. So ignore the red dot, it is no more. Now I need to reflect that over the x-axis. So I'm going to keep these blue. So this will go here and here. So now we're below the x-axis. And then the last piece of this said that we were going to be moving to the right 4 units. So I'm going to finish up with green. So I'm going to go right 4, which will put me here. And this one right 4 would put me here. So this final graph would look like this in its final location. So as I've done some of these word problems, I've tried to group them together so that you can see the main differences in these. All right, these first 2, you have a population that is set at a certain number of organisms initially. So that would be your A value. When you see the word initially here, that means it's going to go in for this A. Down here we have this initially, and it is going to go, I'll do all these in red. These are our initials. It's going to go in for A. Now, the rest of it we have to work through a little bit. So the first thing I'm going to do is P is equal to, for this one we have 15,000. And then B for us is not just B, but it's 1 plus or minus R. Okay? So for us, we are growing. All right? So if I'm growing, this is a plus sign. And then we have 5.6%. So I have to change that to 0.056. And we raise that to the t power. So it says to find the equation given over time t. So this would be 15,000 is your initial amount. You have 1.056 raised to the t power. And that's all that question wants you to do, is come up with an equation. Now, you need to recognize that this is bigger than 1 and it is growing. Those are 2 things that you need to make sure you connect in your mind. So for this one underneath it, we are again starting with P is equal to, so our initial this time is 13,000. And instead of a B, we are given a rate, and this time it decreases. So we have to subtract, and it's 2.1%, so that's 0.021. And you raise that to the t power. So we are going to have P is equal to 13,000, and if we subtract 1 by 0.021, we will get 0.979 to the t power. And that's all it wants. It's just looking for equations of these. Notice again, this number is between 0 and 1, so we are in fact decreasing. This question is talking about a fox population in a certain region, and it says that you have annual growth rate of 6% per year. All right, so I'm going to put rate is 6%, and it is growth. Okay, next thing it tells us is that it's estimated that the population in the year 2000 was 15,900. And then I'm going to go ahead and look right here, and it says t equals 0 for the year 2000. So I have ordered pair point 0, 15,900. And it says that it wants us to find a function that models this population. So this is very similar to the one we had before. The only thing I'm missing is the word initially. So since this is time t equals 0, this is your initial population. So we're going to have P of t, and this is going to be equal to a b to the t again. And again, we're going to have an initial value goes first for a, so 15,900. And b is 1 plus our rate, and our growth rate, so it's growth, so we're going to add, and we have 0.06, and you have to raise that to the time t power. So P of t is equal to 15,900. Your base is 1.06 to the t power. And again, we're checking to make sure that we are in fact growing. So our base b is 1.06, which is bigger than 1. So this would be your A answer. B answer says use this equation to estimate the fox population in the year 2000. So in the year 2008, 2008, that is not what we're going to put in for t, because we use t equals 0 for 2000. So if I'm looking at the year 2008, then t would be equal to 8. So we're going to do P of 8, and that's going to give me 15,900. And then I'm going to take 1.06 and raise it to the 8th power. And this is where you can't forget PEMDAS. So the first thing I'm going to do is deal with this exponent. So on my calculator, I'm going to be typing this in. I have 1.06 raised to the 8th power. Gives me this big long decimal. So I have 15,900. And this will give me 1.593848075. And then we're going to multiply that times 15,900. Now, the answer we get is 25,342.18439. And since we're talking about a fox, then we are going to truncate this. So your answer would be 25,342. Our next question is talking about purchasing a vehicle for $27,500, and it tells you that it depreciates at a rate of 8% per year. So depreciation is a decay, which means that we are going to be subtracting, all right, subtracting 0.08 from 1. It says determine the approximate value 14 years after purchase. So round to the nearest whole number. So this is going to be f of x, or f of t, let's do t. F of t is equal to a b to the t. F of t is equal to my initial amount that I paid for the car was $27,500. My base is 1 minus the rate of 0.08, and I raise that to the t power. So this is my equation, and 14 years after purchase would be f of 14. So we know that when you buy a car, it goes down in value very quickly. And this is going to show us exactly how quickly it goes. So this is 0.92 to the 14th power. So be sure you do 0.92 raised to the 14th power first. So I have 27,500 times this decimal, 0.3111928,305. And when I multiply that by the 27,500, it tells me that this car, after 14 years, is worth $8,557, and it would have been 80 cents, okay? So we have to be careful about how we round. So as I'm looking at this, the 8 we'll of course push the 7 up, so this car would be worth $8,558 after 11 years. So the next two we're going to do don't have any kind of a word problem with them. They're just giving you some information. So because I have in this first one the points 0, 2, and 2, 8, 0, 2 is my initial, so A is going to be equal to 2, so that would go here. But now I can't automatically look at the other ordered pair points to figure out the rest of it. So what we're going to do is write down f of x is equal to ab to the t. And I'm going to substitute 2 in where my a is because it tells me 0, 2, so that is my initial value. Now, I am now finished with that ordered pair point, so we're going to move to this one. So I'm going to go to the other column. So I have f of x is equal to 2 as my initial, and then b to the t power, and I'm going to plug this in. So my y value is 8, a is still 2, b is still b, and the time t is 2. So I'm going to divide by the front 2, so that gives me 4 is equal to b squared. And then if I take the square root of 4, I'm going to have b is equal to 2. On this next one, we are giving an initial value here of 12,000. So this is f of x is equal to 12,000. And then we have b to the x power. And now I'm finished with that ordered pair point. I come over here. So I put 6144 in for my y value. And then my x value, of course, is going to be the number 3. So we put this in. So I'm going to divide both sides by 12,000. Which is going to give me 0.512, and that's going to be equivalent to b to the third power. Now, these numbers are going to get confusing as we go, and I'm going to try to show you the easiest way to do this on your calculator. So if I want to raise 3 so that it is raised to an exponent that is going to give me a resulting exponent of 1, you would be raising it to the 1/3 power. Now, what that does is those 3's will cancel, and I'll have b is equal to. So on your calculator, you're going to use a parenthesis 0.512, close the parenthesis, use the caret key. So you're going to have 0.512 in parentheses on your calculator. You're going to use a caret key, and then you're going to open a parenthesis, and you're going to type in 1 divided by 3 and close the parenthesis. Now, your calculator is very, very particular that you use the parentheses in all of those locations in order to get the right problem in there and get a result of 0.8. Now, that means that my equation is f of x is equal to 12,000. My base is 0.8, and then that's raised to the x power. If it wants fractions, then that would be changed to 4/5 to the x. And then your initial is still 12,000. So be careful to see which one it wants. If it does not specify, it should take either one. This one is the most complicated of those that don't actually have an ordered pair point with them, because if you look at these ordered pair points, I do not have the initial value. So these are going to take us just an extra couple minutes. So we started out the same way. We're going to have f of x is equal to ab to the x. And I'm going to go ahead and write it twice because I don't have an initial problem. I don't have an initial value. So what we have to do is work with both of these at the same time. So I'm going to take -1 and I'm going to plug it in for my x. So this will be b to the negative first times a. And the y value for this one is 3/4. All right, now I'm going to go to the other ordered pair point. So I'm going to put 3 in for t, or x. Let me change that to an x. This is x. So I'm going to plug 3 in for my x, and then a I still don't know, and then this b value is 192. So what happens with these is I have two expressions that have both a's and b's in them. So we have to solve for one of those two variables. So it's going to be easier for us to solve for a because the exponent is a 1. So this is 3/4 is equal to a over b to the first power. So in order to solve this for a, I just need to multiply b on both sides. So this is 3/4 times b is what a is equal to. And I'm going to hold on to that. I'm going to circle it because I'm going to use that in just a minute. Now I'm going to go to the other side. So on this side, I just have a times b cubed. So in order to solve that for a, I'm going to divide by b cubed. So we have that a is equal to the number 192, and I'm going to divide that by b cubed. So I'm going to block that off. Now, I have two things that a has to be equal to. So what we do is set them equal to each other. So I have 3/4 b is equal to 192 over b cubed. So our goal here is to solve for b. So I need to multiply this side by b cubed to get it out of the bottom, and I have to multiply this side by b cubed to keep it equal. So those are gone. I have 3/4 b to the 4th power, because this has a 1 with it, and that's equal to 192. So in our hope to solve for b, I have to get rid of 3/4, so I'm going to multiply by its reciprocal, 4/3, so that those cancel. And if I multiply over here by 4/3, I'm going to get what b to the 4th has to be equal to. So 192 times 4, and then divide that by 3, I'm going to get 256. Now, the nice thing about this is I can use that same process that we used a second ago. So if I have an exponent of 4 and I want it to turn into an exponent of 1, I have to multiply 4 by 1/4. So we are going to do that on both sides so that those 4's cancel. So now I'm going to know what b is equal to. So if I take 256 and I raise it to the 0.25 or 1/4 exponent, I get the number 4. So I'm going to block that in, because now I can use that to go back and figure out what b is. So I'm going to take this value for b, and I'm going to plug it into one of the two a's equals equations. So this one is going to be just a tad bit easier. So if I have a is equal to 3/4 times 4, then my 4's are gone, and a is equal to 3. Block that in. So I have my equation is going to be f of x is equal to a, which is 3, and then my base is 4 raised to the x power. So those take just a couple more steps, so be careful when you set those up to be very mindful of where your b goes and then how to solve for it. Next one is a concept that you have heard in chemistry, that if you have a radioactive substance, it decays exponentially, so it has a half-life in general is what we talk about. This one says that a scientist begins with 150 milligrams, so 0, 150 is one of my ordered pair points. This also gives me my initial value, so I know that a is equal to 150, so I'm going to plug that in to my equation. So I have f of x is equal to 150, and then I still got to figure out what b is, and that's raised to the x power. So the second equation, or second sentence rather, says that after 15 hours, there is 75 milligrams of the substance remaining. So what that equation is going to do is give us our function. So I'm going to plug 75 in where my y is. 150 is still my initial value. B is what I don't know, and then x is going to be 15. So the first thing I do is divide both sides by 150, which is going to give me 1/2, or 0.5. If you like decimals better, do that. All right. So then from here, I want to raise this again. I'm using the reciprocal. So I'm going to have 0.5 or 1/2, whichever way you want to type it, will give me what my b value is when I take it and raise that to the 1/15th. Be very careful with your parenthesis sets. And we get this big long decimal. So I have 0.95484160039. So this is my b value. So my equation for this radioactive substance is 150. F of x is equal to 150. My base is the big long decimal we just found. If it doesn't tell you where to round, you're just going to go ahead and type them all. And then that's raised to the x power. Now this is the equation that models how this substance is going to decay. Now if we go back up to our question, it says how many milligrams will remain after 24 hours. So what that wants us to do is evaluate F at 24. So I have 150. I have this big long decimal that if you'll leave it in your calculator, it'll save you some typing. And we raise that to the 24th power. So if it's already in there, you can caret key to the 24th, you get 0.32987. Multiply that by 150, and after 24 hours, we will have approximately 49.48154,665 milligrams remaining. So you're going to have to come up with these equations if they don't give them to you, so be careful with those. In this next one, we have a car that's valued at $29,000 in the year 1990. We are going to write that as an ordered pair point 0, 29,000, meaning that that's my initial value. Remind yourself that this is the year 1990 because we're going to have to do something with that in just a minute. And then it depreciated to $13,000 by the year 2005. So in 2005, we will have gone 15 years into the future, and it's worth $13,000. So the first thing we need to do is come up with our equation. So we've got f of x is equal to 29,000 is my initial, and then I'm going to have b to the x exponent. So we have f of 15 is equal to the 29,000 b raised to the 15th power. And I know that f of 15 is 13,000, and that's equal to 29,000 b to the 15th power. So we divide by 29,000 next on both sides. 13 divided by 29 gives me a decimal 0.4482758621, and that's what b to the 15th power is. So we raise both of these to the 1/15th power. Be very careful with your parentheses. And this gives me a b value of 0.947915643. And once I have that, I'm going to substitute that back up here to come up with the equation that I need. So I'm going to just take this over to the side here. I have f of x is equal to 29,000. And then I have this big decimal that we just found, 0.947915643, raised to the value of x as an exponent. Now, the first question is wanting to know what the rate is. So we have to remember that this is 1 plus the rate. So if mine is 1 plus the rate, and that gives me 0.947915643, we know that it's depreciating, so we subtract 1 from that decimal, and we end up with negative 0.052084357. So that would be my rate. If it wants it as a decimal, you're going to move that decimal, as a percentage, you'll move that decimal. So you'll have negative 5.2084357, and you're going to round that to where it needs you to round. Now the next question wants to know what happens, if it continues to drop, what will it be valued in 2009? So I'm using this same equation that we had here to go between 2009 and 1990. I know that 19 years has passed. So this is f of 19. And using that exact same equation that we had, we raise that now to the 19th power. So we keep the 29,000, and when we raise that decimal to the 19th power, we get 0.3619296,104. And when I multiply that by 29,000, we end up with $10,495, and then we have 9587 cents. Now these are telling you to round to the nearest $50, so the 9 will be bumped up to 100. So the value rounded to the nearest $50 would be $10,500. The next set of questions is going to be dealing with compounded interest, which you all have done in personal finance. So this shouldn't be a new concept, but some of you maybe have forgotten this equation. The biggest thing that we miss on this quiz is that we forget this equation. So make sure that this is memorized. It will not be given to you. All right, so you have A is the amount in the account after a given set of time and also at a given rate and compounded so many times per year. P is your principal, which is what you put in first as a starter amount of money. R is your rate that's given as a decimal, not a percentage. And then N is the number of times it's compounded. So I have several here that you might see: annually, semi-annually, quarterly, monthly, and daily. Then we have one that's called continuously. Now, you will have things other than money that you have to deal with this, but if it talks about money, then you will be using the top equation unless it says the word continuously. If it does, then you have A equals PE to the RT. If R is positive, then it is growth. And if R is negative for the continuous, then it is decaying. So write this page down and then move on to the next slide. So for each one of these problems, your principal is going to be $3,000. That part's not going to change. You also know that your interest rate is 10%, so that's going to be 0.10. So for the first one, you have 13 years. If it's compounded annually, that is N equals 1. So the amount that we are to expect is the principal times 1 plus R over N. And then you're going to raise that to the power N times T. So the amount we're looking for is the principal, 3,000. And then you have 1 plus the rate, which is 0.10 divided by 1. And then you're raising that to the 1 times 13 years. So just because those are ones doesn't change anything. It just means that that's one less calculation you have to do. So this is 3,000. And then your base becomes 1.10, because 0.10 divided by 1 is just 0.10, and you're raising that to the 13th power. So you take 1.1 and raise it to the 13th power, and you get a decimal of 3.4522, and you'll keep all those decimals. So you're going to multiply that times 3,000. And after 13 years, you would expect to have $10,356.81. Now, I don't know where it wants you to round. It might be the nearest whole dollar. You'll just have to read online. If it doesn't tell you to round, then you want to keep all the decimals. So the ones that my calculators show are 0.81364. Now, in the actual banking industry, you would round to the nearest penny. So that would be $10,356.81. Now, for the other two, you are dealing with the same thing, but you're talking about it being quarterly. So what that does is change this into fours. The rest of the problem is exactly the same. It's just that you're going to take 0.10 and you're going to divide it by 4. So that my base is going to be 1.025, and then we're going to raise that to the 4 times 13th power, which is 52. So the calculation still is 3,000 out front. You take 1.052 and raise it to the 52nd power. Again, we get this big long decimal, bunch of ones, and then 2, 3, 4, 9. And when we multiply that by 3,000, we would expect to have a total in this account after 13 years of $10,833, and then it's 0.33705. So depending on where it tells you to round, that would be 34 cents. The next one says that we are compounding monthly, so that's N equals 12. So again, this whole process is going to start over, and instead of dividing by 4, we are going to divide by 12. Divide there by 12, and then we'll multiply here by 12. So again, you keep your 3,000. 0.10 divided by 12 gives me 1.0083 repeating. So you want to put more than just 1 3 out there. And then 12 times 13 is 156. So we raise the 1.0083, all the threes, raised to the 156th power. We get 3,000 times the decimal, 3.649584,184. And when we multiply that by 3,000, we end up getting an amount of $10,948. And then you have 75255. So depending on where it tells you to round, that would be 75 cents. Now the last one is the only one that is different. The information that you start with is identically the same, but what happens is we're not using that equation anymore because we have the word continuously right here. When it says continuously, then our equation turns into P equals, A equals, the amount that we expect to have is equal to the principal times the base of E to the RT power. So the amount that we expect will be the principal, which is 3,000, times the base of E. Your rate is 0.10, and we are still going for 13 years. Now 0.10 is positive, so it is positive because it is increasing. So this is going to be 3,000 E to the 1.3. So you take your base of E and you raise it to the 1.3 power, and you get 3,000. This will turn into the decimal 3.669296668. And when we multiply that by 3,000, then we would expect an amount of $11,007.89. This next question is the Fox population question. The difference in this question and the one we already did is that you have a continuous growth rate. It does not say annual growth rate. So this equation is in a different format. This one is going to be they use P. P of T is equal to the original amount, initial amount, which is 27,100, and you're going to raise that E to the rate. So rate would be 4%. So that's 0.04, and it's positive because it's growth. And we're going to raise that to the T power. So find a function that models that. So this is A part. That would be what you would type in for the A. Now it says to use this to estimate it in the year 2000. So we're using T for equals 0 for 2000. So what we're going to do in B part is to do P of 8, because that would be 8 years after the year 2000. So we do 27,100 E to the 0.04 times 8. So this is going to be 27,100 E to the 0.32. So we raise E to that exponent. Make sure you use your base of E. Raise it to the 0.32 power. So this is going to give me 27,100. And then this decimal is 1.377127764. And when we multiply that by 27,100, we end up with a Fox population of 37,320.16241. And when we round that to the nearest integer, you would drop that decimal, and that would be your answer. The next one wants us to use our graphing calculator. So what I've done here is this red equation is what they gave you. That's this equation right here, 1,450 E to the 0.21x. So that's the red that you can see. It's exponential. And then the blue is 6859. So then you're going to zoom in on this area. So that's over in this window. And when you focus that in there, you're going to end up with an X value of 7.39999. And I think it might tell you to round to the nearest tenth, which would be 7.4. So after 7.4 years, the population will be that large.